Assuming you've watched the previous videos in this playlist, I'm going to point you to another function in the OLC Pixel game engine. It's called drawDecal. Now, to give you some layman's terms, drawSprite uses your CPU and your RAM, while drawDecal uses your GPU and your VRAM. The code itself is simple, so let's get the function working first. I'm going to create a data type called decal. I'm going to create a pointer and call it decalPTR. And if you don't understand pointers, make sure you check out the previous videos in this playlist. So instead of the sprite, I'm gonna create a decal pointer. The only difference is that I'm gonna use the sprite to create the decal. It's just another layer on top. And instead of drawSprite, I'm gonna use a function called drawDecal, use the decal pointer. So the decal pointer uses the sprite pointer, and the sprite pointer gives you the actual PNG file. If I press F5, okay, we're now using a different function, but the result is the same. And of course, when you use a pointer and the new keyword, when you're done using the pointer, you delete the dynamically created object. And I'm going to change the PNG file. I already have something downloaded in my downloads folder. Okay, it's called Titanfall Mech. This is it. I'm going to copy paste it into the folder that the project is in. Open folder in File Explorer, paste it in there. This is the same folder as the smiley. This is the root folder for our project. I'm gonna get back to my project. Let me also copy the name because I want to put the name here. F5. Okay, now we have the new PNG file instead of the smiley. Let me also change the position to 0, 0. Let me press F5 again. Okay, it's being rendered. And you can also see that the transparency is already taken care of for you when you use the drawDecal function. So that's nice. Now the drawDecal function uses something called OpenGL. If you're a PC gamer, you've probably heard of OpenGL. It's an API, and an API stands for Application Programming Interface, I think. But just to give you the layman's terms, OpenGL is something that sits between you and your GPU, so that you can interact with the GPU and you can render stuff using the GPU onto your computer screen. Now there's many types of GPUs, all with different specs, built by different companies. It's unrealistic for you to write code for every single one of them. Instead, we rely on OpenGL to do that for us. So instead of worrying about things like how much VRAM you have in your machine or whether a texture has been loaded onto it correctly or not, you just tell OpenGL what you want. You tell it which sprite you want to load or which sprite you want to render. When you're starting out, you don't really have to understand how OpenGL works. You can later, as you gain more experience, you can get back to it and learn how it works. But when you're starting out, you just need to know how to tell the API what you want. And in this case, you might not even have to know that because the OLC Pixel game engine does it for you. But if I look at the decal constructor, I'm going to press F12, go into the definition. And these two functions are a way of telling OpenGL which sprites you want to load. We also give sprites an ID, so later you can find exactly which sprite you want. And if you go deeper, you're going to find some OpenGL functions. But for this video, I'm not going to talk about OpenGL. It's a massive topic. If I do decide to talk about it, I'm probably going to have to set up a separate playlist for this. But for this video, we're not too worried. We know that the OLC Pixel game engine uses OpenGL and it works. If we also look at the update, I'm going to look at the drawDecal function, and you're going to see that we're saving render related data into individual objects called decal instance, and we add every instance into a vector. If I also follow the vector, find all references, if you do, you're going to see that this happens after the onUser update. So when we render, we go through every instance in the vector and we say draw decal quad. We tell OpenGL that we want to render based on the data inside the vector. Again, I'm not going to go into OpenGL in this video, and these are also older functions. Today there are newer versions of OpenGL with better optimization and everything. Later I might decide to come back and add my own updates, but for the most part, this is still good enough for most 2D indie games that I can think of. It'll still give you better performance than the draw sprite function. You might ask, why are GPUs faster in terms of graphical tasks compared to CPUs? Usually, it's because your CPU pretty much runs everything. It runs your operating system, it runs your game logic, it runs as well as all the other apps that you happen to be running at the same time. It's basically your brain for your machine. Whereas with the GPU, it's only concerned about one specific group of tasks. It's only concerned about doing that really well. You might have noticed that every year there's big talk on the latest GPUs and VRAM and all that. Modern video games tend to require a lot of graphical calculations for every single pixel on your screen. For example, if you think of raycasting, it's pretty much calculating every light particle path and how they bounce off every surface in your game scene. If you've been watching my previous videos, especially the ones on permutations and combinations, you'll see that there's going to be a lot of calculations regarding every single combinations, regarding every light sources and every bounces on every surfaces. In case with 2D games, your GPU is going to play probably a less vital role, but you're still going to see a noticeable difference in performance. I recommend reading the documentation on the OLC Pixel game engine. For now, you don't have to worry about the APIs. You can always come back later and dig deeper, and you'll probably also notice that there's many other options like Vulkan or DirectX. For now, we're mostly concerned about the interaction between the 2D sprites, which is probably already enough for you to build your own 2D game. So for your homework, try rendering different sprites, whatever is your favorite. Also try drawing your own textures and render them on your game window. So that's it for this video. If you have any questions, you can reach me on my Discord server. I have all the links below. Thanks for watching. I'll see you next time.